what you guys think. Okay, cool.
All right, got it. So shall we start?
Well, maybe I could introduce what I think we have as common ground. So Roy Mike is a biologist. He does very technical work on bioelectricity and how cells intelligently communicate and self-organize into complex systems. And Roy is a social psychologist, one of the world's most famous social psychologists. So he's written on basically everything, but most notably, in my mind, he's got a book on self-control, or a book on what is the nature of the self. And recently, another book on free will, which you and I have talked a lot about. And I see myself somewhere in the middle between you two, doing developmental cognitive neuroscience. And I think we all have in common these shared philosophical interests in the self and self-control, self-organization, and what are the biological evolutionary mechanisms behind all that.
Cool. Well, self-organization, I think, is one of the deep mysteries of the universe, or one of the most important things by which we get from electrons floating around in the ether to the global economy.
Yeah, and people actually, so this is great. I'd love to hear your take on a few things, because people ask me all the time. So I study kind of the journey that we take. We start life as a single cell, this unfertilized oocyte, and then you get to be an embryonic blastoderm, which is this like flat disc of, I don't know, 50,000 cells, and we look at that and we say that's one embryo. Well, what are we counting when that's one embryo, right? What's going on? And so I study this slow process of this emergent self, where all the cells are committed to the same goal in anatomical space, and the collective intelligence of these cells, and dealing with novel problems they haven't seen before and things like that. And people often ask me, they see this stuff and they ask, well, what are the implications for social structures, right? Can we scale that up? Because I often talk about scale-free dynamics that you get in molecular network cells, organs, and so on. And people naturally will say, like, what are the implications for social structure? So yeah, I'd love to hear your take on the self, the social self. How much you think how much of this collective intelligence stuff you think is in fact multi-scale, that you can talk about these things meaningfully at a higher level. Yeah, I'd love to hear that.
Well, there's the common process of, again, self-organization, of things lending themselves or taking on parts of larger systems. I don't know that the one by which cells become single cells become embryos and embryos become babies, I guess, would be the same as by which people merge into groups, and groups merge into nations, and like I said, nations merge into the global economy. It's just that, I guess, with the global economy, they discover advantages. So like globalization is coming whether we like it or not, because it makes the system work better and ultimately creates more resources, which filters down to individuals benefiting. If it filters all the way down to the embryos, I don't know that embryos work any better because of multinational corporations or international trade. But maybe they do. But still, there is the common practice of moving up toward greater systems.
Yeah, I mean, what we see is that there are certain basic principles by which these things connect that allow them to do two interesting things. That allows them to scale up the goals that they're able to pursue. So single cells pursue little tiny local goals, but cell groups can pursue very large goals, like making limbs. When I say pursue goals, I don't mean emergent complexity. I don't mean kind of this open loop process where there are a bunch of simple rules. They all follow these rules, and complex things come out. I don't mean that. I mean, beyond that, there's a second order situation where what you get is actually a system that is able to specifically pursue certain goal states. And if you try to deviate, it will find ways to, actually quite clever ways to get there. And the scale of those goals gets bigger and bigger, but also in other problem spaces. So cells start off solving problems in physiological state space, in gene expression space, and so on. But embryos, groups of embryos, solve problems in anatomical space. And then, of course, animals with nervous systems will also solve problems in three-dimensional space and move around, and then eventually linguistic space and so on. So yeah. So what, I mean, what are some of the principles that that you think underlie the scaling, and you know, in your area, when you go from individual people upwards, what are the policies that underlie all that?
Yeah, all right. I was going to ask you what are the principles at the cellular level, okay. I mean, there's the obvious point. If any of us was plunked down in the jungle alone, we'd have a hard time surviving, let alone reproducing or making a comfortable life. So there are advantages to the individual person to being part of a group. There's safety in numbers, I guess, basic communication in the simple herds. Humans do a lot more with shared information and division of labor and things like that. Division of labor is, improves what the economists call the efficiency of a system. So that the same amount of work by the same amount of people can produce more resources. I would say, like, if I had to, I'm a professor, if I had to catch my own food from nature and build my own shelter, it would be in sorry condition. I don't have those skills. But with division of labor, everything is done by an expert, a specialist. And so things get done better. And then there are economies of scale, which is why the large corporations can basically outcompete the small ones. So again, the same amount of effort, work, the same amount of energy expenditure produces more resources in the larger, more complex system. Now, is that true at the more basic level also?
Yeah, so far that all tracks pretty exactly.
Good.
You know, I also wonder, so there's this other phenomenon that you can call something like a cognitive glue, where imagine you've got this rat and you train it to push a lever and get a reward, right? Well, so it forms this associative memory that pushing the lever is associated with getting a reward, but there's no individual cell in that rat had both experiences. So the cells at the bottom of the foot touch the lever, the cells in the gut get the reward, but no individual cell had that experience of both.
Right, yeah.
Right. And so the memory, that associative memory, is owned by the rat. Well, what's this rat? This rat, I mean, it's a bag of cells, but it has a mechanism for doing credit assignment and memory of things that belong to the collective and not to any of the individual cells. Right. That's one of the cool things about being an emergent individual, is that you get to have memories that none of your parts have. So I'm curious as to, okay, and so what that means is that you become trainable as a collective. So you can train the collective on things that no individual in that collective actually knows, but the collective knows. So I'm curious if you think that societies, corporations, whatever, you pick the level, whether those are trainable. You know, we did a project once trying to train an ant colony, not the individual ants, the colony, right? The collective intelligence of the colony. And we didn't get to finish it. It's sort of inconclusive, but I wonder if anybody's done those experiments, and I wonder what you think the prediction would be, whether collections of humans, not the individuals, but the group, is actually trainable.
I wonder if this connects to Roy's idea of ego depletion, where he's shown that across a wide variety of tasks, it's almost like people have this finite pool of cognitive resources or of effort. And if there could be some sort of computational mechanism underlying that, where, say, any of your individual neurons. It's not like they get tired, but collectively, regardless of what problem you're working on, there's some generalized pool of cognitive resources that you're pulling from, and then over time, it can drain.
Well, we're starting when we talk about the rat and so on, that there is a central nervous system. You're right that no one cell participates in both the pressing the button and the receiving the food reward. But the brain manages both.
Yeah, but you've got the same problem when you say the brain. There really isn't any brain, right? There's a huge collection of cells. And so for sure, the cells are connected via policies. And so this is the electrical communication, and the same thing happens in the rest of the body that allow the collective to act as though it was in possession of this associative memory. But there isn't one of anything, right? The whole thing is very much a collective, and you need that. You need those policies to make sure that the collective can know things that the individual parts don't know. The brain is particularly good at it, but there are also creatures that are brainless that can do it. There are examples like this in other body parts. I mean, it's not just, but yes, of course, the brain is part of the mechanism of this collective. Yeah.
I had a book on the self last year, and then it struck me it's the creation of unity. Usually the brain learns to process systems and use that to direct the actions of the body. Like walking would be an obvious one, that an animal with 4 legs, the brain has to kind of understand left and right, front and back, and coordinate them to move in alternating fashion, to move forward versus to plant. So the brain gets the whole body to operate as an integrated system by sending out separate commands to the separate limbs based on this integrative system that organizes the whole thing. So that is the emergent organization. Of course, it's very adaptive too.
Yeah, I mean, well, a couple of things. One is, so we study a lot of things that don't have brains, and so slime molds and the single cell organisms, and right, and tissues and everything else. I mean, they all do this stuff. But again, they're all made of parts, as is the brain, where it's made of. I mean, it's very, once you start thinking about what a truly centralized controller even means, it's really hard because everything's made of parts, right? And it's I've got this slide where that I sometimes show in my talks. Descartes was really into the pineal gland because it's the only unitary thing in the head, right? And he felt that our unified experience as humans should have a single locus in the brain. But if he had a microscope, he would have looked in there and said, my God, there's not one of anything. This thing's full of cells, right? And still, right, the hard problem remains is understanding how you're going to bind all these things into a coherent self. And so so I've got this model. What part, because we deal with cells and tissues and synthetic organisms. I mean, we make synthetic life forms and so on, and we deal with all this kind of stuff. I've been trying for a framework that is kind of agnostic about the medium. So what do all decision-making agents have in common that need to act in physiological space, right, in anatomical space and physical space and financial space, linguistic space, whatever. And so we've been working on this notion of a cognitive light cone, which is just the size of the goals that you're able to work towards, and then the different then of course there's different competencies in reaching those goals. But so I'm really interested in that the social question, because oftentimes one of the tricks that we use is we try to take things from behavioral science, tools from behavioral science, and apply them to things that aren't animals with brains. So we've shown, for example, that you can do sensitization, associative learning, habituation, anticipation, all these things. You can do them in the gene regulatory networks already do this, right? So molecular pathways already do this stuff. And so I wonder, and so then people will say, well, that's since you're stretching the cognitive spectrum all the way down, next you're going to say that the weather is intelligent, and they say, well, I don't know, have we tried training it? Like, I have no idea, but it's to me, it's an empirical question. You can't just sort of sit back and make assumptions, right? You have to. So I just wonder. I wonder if the social structures, if they're amenable to some of the same techniques that we use in behavior science to probe collectives, because that's what it is, right? When you ask if something can do habituation or association or planning or whatever, you're probing the competencies of a collective, and I think we could. I assume we could probably test that, but I don't know, right? I mean, you wouldn't. Maybe if anybody's tried that in social circumstances.
I don't.
I've been talking to Roy a bit about active inference and these entropy-based predictive processing theories of consciousness. We've been talking about it in the context of drive for exploratory play, sensation seeking, reward sensitivity, and boredom. But I'm wondering if that generalizes more as this underlying, say, computational mechanism you're talking about that connects between whether it's human cognition or more basic animal cognition, or even these higher order organizational systems, social systems.
Yeah. I mean, we study a variety of connection policies, and one of the let's see if this rings a bell at all. One of the policies is a kind of memory wipe. So if I have two cells sitting next to each other, there's a very particular, so if this cell sends a signal, some chemical signal, and goes out and it hits the cell, that way of communicating, it's very easy for this cell to know that signal came from outside. That's not my information, that's somebody else's information. And so you can choose to believe it or ignore it, or whatever. But there's this magical thing in bioelectricity, which is there are these electrical synapses called gap junctions, and what they do is they connect directly the internal milieus from one cell to the next. And so what happens then is, that's very different, because what happens then is if something happens to cell A and there's a memory trace of it, let's say a calcium spike or something that's a memory trace of that event, it propagates directly into cell B, and it doesn't have any metadata on it that says, hey, I'm coming from someplace else. Cell B sees this calcium spike and says, oh, we've been poked, right? And so now when you're sharing memories, if you and I are sharing most of our memories, it's really hard to keep independent identities. We start to sort of have this mind meld where, and now we're bigger, so we have some bigger computational capacity. We're physically bigger, but also we have a joint memory, and we also are bound to cooperate, because we can't even physically entertain the thought of defecting against each other, because we're sharing the same thought and we are the same informationally, we're the same being to some extent. So that memory wiping property is one thing that I think really facilitates this joining into collectives. Another one is shared stress. This idea that if one cell is under stress, what it might do is export some stress molecules to its neighbors, which then also feel stressed. They don't know that this is somebody else's stress. And so my problem becomes their problem. And so now if I need to get somewhere and they're in my way, now everything sort of gets a little plastic, because they're jiggling around because they're not happy either. Whereas otherwise they would have sat there and not let me pass. So like this sharing of, this globalization of stress. And there's some other stuff too, but I don't know. Does any of that sound relevant?
It starts to look like pheromones, and then you get into my world of hormones and development.
Yeah. Somebody said recently, somebody said to me recently, boy, it's really hard to change your mind and your priorities and they said, I don't know, look at what happens at puberty, right? Like few hormones and bammo, everything changes. All your priorities are upside down, and things that seemed great are now stupid, and things that seemed disgusting are now great. And right, it kind of turns everything out. So it's not that hard, actually.
Well, it's interesting, this collective approach. This is giving me a different perspective. I'm thinking I kind of start from a point one of my philosophy professors made, which is that sort of part of the essence of life is a boundary between inside and outside, and that every living thing maintains a boundary. And of course, stuff moves across the boundary as we eat, for example. But it's still, we know the difference between the hamburger we ate and the one we didn't. that remains outside. And that's long before the self, but there is that boundary, and then the brain presumably evolved within organisms to take care of the whole self within that boundary. So
Right, not only in space but in time as well.
Space and time, yeah. Well, most animals live pretty much in the here and now. The integrating across time, or there are brief expectancies for a few seconds into the future and so on, but only humans really have a full narrative sense of self.
Psychologists say that a lot, that only humans really think about the future. Does that check from your perspective, Mike, that other animals are only really focused on the here and now?
No, I don't agree with that. I mean, I think that, well, it is true that we are the only ones that have a kind of a metacognitive, like we know when we are thinking about the future and so on. But even bacteria and yeast can anticipate future events. So memory and anticipation does not require a brain. Most critters do it. We've shown a kind of
They anticipate events how far in the future, though? Next year?
No, not next year. So that's right. So humans have a much bigger cognitive light cone. So that's part of it, is that we have a huge, and in fact ours is special in another way, because ours is bigger than our lifespan. So you probably uniquely, as far as I know, we are capable of pursuing goals that are for sure longer than our lifespan. In other words, not personally attainable goals, right? Most of these other creatures have a much shorter term. For bacteria and yeast, it might be 20 minutes or something like that.
Okay, that's good. Yeah.
But it's there. And I also think, your point about the boundary is really critical. Establishing the boundary between self and outside world is absolutely critical. I think it happens long before we have a brain, both evolutionarily and developmentally, right?
Absolutely, yes. Plants, clearly. I mean, you can dig up a plant and wash off the dirt and move just the plant and nothing else.
Yeah.
So there's the unity there, but the brain improves your ability to operate that way. So if we look at the collection of cells as a collective, they are somehow learning to act, or evolving to act, as if they are a unity long before there's a brain.
Yeah, and even in human, at the very beginning of human life, you can actually see, and this is, I've done these experiments in duck and so on. When you have this blastoderm and you look and you say, there's an embryo that's going to develop into a human individual. Well, what you can do is you can take a little needle and make some scratches in that blastoderm. And for about 4 or 5 hours before they heal up again, every island is going to basically decide that it's on its own and is going to start making an embryo. And when they do heal, you have conjoined twins, triplets, whatever so the number of individuals in a blastoderm is not fixed. It's not one. It's anywhere from 0 to probably half a dozen, right? And then you get this interest. So this excitable medium just sort of generates individuals, right? And then you get this interesting question, because when you got two embryos sitting next to each other, the cells, every cell is some other cell's neighbor. And so now the question is, am I part of this embryo or am I part of that embryo? Right. And sometimes they get confused. And this is why conjoined twins often have laterality defects, because left and right, they can't quite tell which side they're on. But this issue of deciding, right, where do I end and the outside world begins, is like very fundamental.
Yes, it is. I had a baby girl who didn't cry very much, but one day my wife heard her crying, and she walked in and she was lying there. Her finger was poking herself in the eye.
Right.
She didn't know it was her own arm yet.
That's funny too, because the plasticity of the body, if you've ever seen the rubber hand illusion, you see these videos on YouTube, right, where they put a rubber hand next to you and they sort of you watch them pat it with a little brush and stuff, and then somebody takes a hammer and goes to hit it, and the people freak out because now you think that it only takes 10 minutes to override, I don't know how many millions of years as a tetrapod, like your brain knows exactly how many limbs you've had, but you can override that in just 10 minutes of watching somebody, you know, pat this rubber hand, and suddenly it's your hand. Yeah.
Huh.
It doesn't take very long at all. And that's great. That plasticity, it's why people can have people do sensory and motor augmentation. So crazy prosthetics, right? You know, this monkey with a third arm that uses it to eat marshmallows. You know, in humans, they get prosthetic arms where the wrist goes, you know, all the way around like a normal wrist doesn't. They'll do that when they pick up a coffee cup. They'll go the way that a normal hand would never go. And so, like that plasticity, you know, I think we have to. Embryos have to figure it out from scratch. What do I have? What do I, you know, what sensors do I have? What effectors do I have? Where's the what I have control over? Where is the boundary?
Huh. So they all learn that or figure that out. Huh.
Yeah, and we can do stuff like in the lab. We can do stuff like we can make a tadpole where the eyes are on his tail, and no problem, they can see. We can do visual learning tasks. It all you know, it all gets sorted out. I think it's we have many examples like this of just really. Oh, we make these xenobots, which are frog skin that's given a new life, and it makes this little motile proto-organism that runs around on its own and does all kinds of things. It's just skin. Yeah, I think it's because all of these questions of what am I, what is my structure, what space do I live in, all of this gets solved from scratch when every time. It's not hardwired mostly.
There's some type of built-in error correction, right? Like if you put the eyes on the tail, they slowly begin to migrate towards the head, even if they don't make it to where they're supposed to.
No, the eyes on the tail don't move. What happens is the eyes stay there. There are things that definitely correct. So if we make these so-called Picasso frogs, which are all the craniofacial organs are scrambled. They do correct by the time they get to a frog. They do correct, but you can also teach them new patterns. So for example, when you cut a xenobot, it heals back to its new xenobot shape. And if you have a salamander and you keep chopping off the one limb, after about 5 or 6 trials, it gives up and it's not going to do it anymore. It's done. It learns that it's just not going to work.
And then thinking about that type of self-correction plus this computational Markov blanket idea of identity, and something like whatever the confidence intervals or error bounds are. So on one hand, when we're talking about identity, you have this kind of almost postmodern, it could be anything, right? The boundaries are kind of arbitrary, only to the extent they're functionally useful across time. Are they going to be stable? So the simplest version of this would be, think about what's a Markov blanket that can define the scope of the sun. It can just be a sphere of arbitrary size. And for the most part, we agree on the boundaries, but you could keep extending it, and you're going to capture some residual solar flares. Like you could extend it and define a sphere that goes all the way out to Mars, and you're going to collect even more of that solar mass, but it's kind of like a diminishing returns type thing. So there must be some optimum point if you define a function that, say, on one hand, you want to maximize the amount of sun you're capturing, but on the other hand, you want to minimize the amount of like false positive or empty space. So you're trying to optimize across those two variables. And then I'm wondering at the level of the boundaries of an organism, if you have something like that too, where you can have all these philosophical questions of, am I still me if I take away one skin cell? Yes, or even a hair. But you keep removing cell by cell, eventually there will be no more of you left. So it must be something like you do have boundaries, but they're fuzzy boundaries. And there's something like these confidence interval bands of how much can you remove before you actually no longer have the thing.
Yeah. Yeah, I think that's super interesting. And I think there's a couple of things that feed into this. One is that people, so I was just reading about this cool example where, blind sight, where someone doesn't think they can see, but in fact, if you ask them to guess what's in front of them, they guess correctly. And so they in fact can see, they just don't know they can see. There's the original patient that was studied for this would say that that's not part of him. It's that vision, it's something else. It's something extra. He didn't think that was part of him because he didn't have a direct perception of it, even though it was part of a successful part of his behavioral repertoire, it wasn't something that he had conscious access to, and he didn't feel that was part of the self. So that's asking, but we also have to keep in mind that's asking his left hemisphere, presumably the one with speech, right? Because there's actually another hemisphere in there that you don't normally hear from, and there are a whole bunch of other stuff in there that we don't know how to talk to yet, right? Other organs and so on that might have their own boundaries in different spaces. And that's also on a practical level, that's also what we deal with when we work on cancer. So when we work on cancer, what you see is that when individual cells electrically disconnect from the rest of the body, their cognitive light cone shrinks, they're back to their amoeba, tiny little amoeba goals, and as far as they're concerned, the rest of the body is just environment to them, right? And similarly, when we make these xenobots, you start with a frog embryo, you dissociate it into individual cells. The cells are all alive, and you take some of them and you make the xenobot, but the embryo is gone, right? The tadpole is gone, and so where did it go? And right, because the cells are all alive, and it's exactly what you just said. You could sort of take one after the other, and then eventually you have something else. You have a bunch of loose cells, or you can make a xenobot or something, but the individual is gone. So yeah, these boundaries are fuzzy indeed. And then in fact, I mean, that's the other the end point of the story then is that you can actually go backwards and you can force these. And this is a cancer approach that we work on, which is to not to kill those cells, but to force them to reconnect to their neighbors. And when they reconnect to the neighbors, they once again become part of the collective that's working on making nice skin, nice muscle. They stop being metastatic and they go back to.
Wow.
Yeah, and yeah, we've done it in frog. It works great in frog. We're now moving into human cells, but it's a different, right? It's a different way of thinking about it, because you take advantage of that memory wipe. They forget about their little local goals and they start working on whatever the collective goal was. By the way, I was going to. Yeah, go ahead.
How far does the cognitive light cone extend? Because when you talk about, say, humans are the pinnacle of that, like our subjective experience of being one, and then you can go narrower in all of the sub levels, down to the cellular level within humans, and all of those are narrower versions of that light cone. But when you expand across humans, it seems like there's not only a jump to me and to you and to different selves, but there's not the same like connecting continuum that. So, because on one hand, I'm tempted to say you can look at broad scale social organization or like network dynamics as an even larger portion of that light cone, but it doesn't seem to have the same continuity.
Well, I don't. You mean it doesn't like first person continuity? Like it doesn't, like you think it doesn't? It isn't like anything to be that social agent,
right? And we both are, I think, sympathetic to panpsychism. So saying even if we only have conscious access to what it's like to be us at this higher level, like it's possible that there's something that it's like to be a cell, but I'm not sure it's possible that there's something it's like to be, say, a country.
There's actually a really good paper about that, which I will I'll look up in a minute, and I'll try to put on the chat, that actually talks about the kind of the philosophy of that. So sorry.
What is it like to be a bat?
No, there's another one that's there's a different one. I'll find it momentarily. Okay. But I don't know. I think that if we didn't know any cell biology or neuroscience, and somebody said to us, "Did you know that?" Here's what I think. I think I could take 3.5 pounds of these little electrically excitable things and smush them together in this process where the whole thing kind of folds on itself for 9 months and whatnot. Did you know that that's going to give rise to an internal perspective of a human? I would say, hell no. That doesn't sound plausible at all. I think we have no idea what kinds of things give rise to those kind of first person perspectives. I don't think that necessarily just because you're bigger in scale, I don't think that necessarily your light cone is bigger. So I wouldn't make the claim that necessarily groups of people have a bigger cognitive capacity than individual people. In fact, I don't know, Roy, you could say what you think about the intelligence of groups versus single individuals, but I don't think there's any reason why it has to be bigger. But I also don't see we don't, our intuitions, I think, for what is sufficient to have that inner perspective, I think, are really badly calibrated. I don't think we have a clue.
I'd be inclined to think you'd need a brain and central nervous system to have conscious experience.
I mean, that's fine, except that the brain and nervous system show up very slowly. So that both evolutionarily and developmentally. So that means that we need some sort of a story about when does it kick in. And I've never heard a good story about that.
Yeah. I've long speculated that the first conscious experience would be pain. Just that would be adaptive, and there was a signal that the tissue is being damaged.
That's perfectly reasonable, and that would be the disruption of a cell membrane in a microbe, because that depolarization that neurons have when you trigger them, which presumably they don't like, and so on, that is as old as the hills. That's pre-multicellularity, never mind neurons. But I agree with you. Yeah, that kind of basic damage and that physiological, that delta from physiological homeostasis is the origin of it, but it's really old, you know.
Yeah, good. Well, to get things, this is sort of the other side of your example of the rat no cell experiencing both the bar press and the food reward. But with pain, you step on I don't know, fire ants, and the brain says ouch, and grab onto something and pull yourself away. That would be the same thing. It's a whole body response, and perhaps you could find an example in which no one cell is involved in both the input and the output. The input being the signal of pain, and the output being the motor movements to escape it.
Yeah, want to see something fun? I'll show you a quick video. Hang on a second. Let me. Yeah, this is cool. All right, can you guys see this thing?
Yeah.
So this is the work of postdoc Narosha Murugan in my lab, and what this yellow thing here is a piece of slime mold. The slime mold, you're going to see it grow, but the whole thing is one cell. It really just has one. It's one big cell. This is a glass, a very thin glass disc. It's about 5 milligrams. There's no food. It's just glass, inert glass. This is 3 glass discs. Okay. So here's the time lapse. And so what happens is, for the first few hours, what the slime mold it's growing in all directions, right? But what it's also doing during this time, which you can't see, is it's gently tugging on the medium and reading back the vibrations that it gets from pulling. It's sitting on a soft agar, and it's pulling on the soft agar. And by right around this time, it's made up its mind about where the bigger mass is. And how do we know? Because boom.
Whoa.
Yeah. And this is reliable. What it will always do is, not quite always, but most of the time, what it'll do is it'll go to the bigger mass. We don't know why it likes a bigger mass. Who knows? But what it's able to do, and the coolest part to me, is right here, because at this point, it's already integrated the information about its environment. It already knows where the bigger mass is, but hasn't done anything yet, right? Up until now, this is all from here, the first 600 minutes or so. This is all pondering time right here. This is where it's collecting that information, and the whole thing is one cell, and it's collecting this biophysical sort of feedback from its environment, and then bang, at this point, it's right like here, 795, it's still sort of, it could go in any direction, but boom, that's it. At this point, it's made its choice, right?
Very nice. Yeah.
The whole thing is one cell, and we have tons of experiments looking. You can test it. And other people like Audrey de Sautour has done training. You can train them. It has memory. You can train it. You can take a trained one and a naive one and fuse them. They'll fuse together, and then the memory sort of propagates, and the naive one will now remember, have the memory that the other one had. No nerves, no brain, single cell.
Wow.
Mike, we've talked a lot about zooming in, down, and back on the evolutionary ladder. Like there's no obvious point at which intelligence emerges, and there's a nice elegance to panpsychism. Like it's always there, and it's just on a continuum, and maybe there's some bare minimum unit of consciousness. But if you scale it upwards again, past humans, even past social networks, at the most extreme level, you would have, okay, treat the entire universe as a single system. You get this kind of pantheist cosmopsyche mind of God in Spinoza's terms. What do you think of that?
Yeah, I mean, well, first of all, I think though, I think all of this is an empirical question. In other words, I don't think we can assume in either direction. I think you have to do experiments. So when you have some sort of weird collective and you want to know if it in fact, you want to know what kind of cognitive system it is, you can do experiments like we do with everything else in behavioral science. You can give it stimuli, you can see if it has memory, you can see what the kind of attention keeping properties it has. I don't know how you do experiments on the whole universe, but you could, for example, I've talked to physicists to try to design a planetary scale synapse. So you could do it. You could have a system where there's a gravitational system, and you can send objects through as stimuli, and it will sort of permanently change the way that would react to new objects in the future. So basically synapses. You could imagine building a gigantic nervous system out of something like this. I have no idea if we live in one or not, but I think I think it's not impossible, and I think that we probably are not going to be able to. I don't know. I'm sure there's some kind of Gödel thing here about not knowing for sure if that's what we live in. I work with this amazing graphic artist, Jeremy Gay, and I've asked him to make a little cartoon, and it's a cartoon of two neurons in a brain, and they're talking to each other, and one neuron says, we live in a cold, mindless universe. Nobody cares what we do. There's nothing out there. And the other neuron says, I don't know. Every once in a while, I get this idea that there's something. There's more here. The universe is sort of, it wants something from us. It's there's got some kind of order to it. And the first neuron's like, you're crazy. There's nothing. There's no mind out there. And and they're both part of this big brain, right? And so in that case, the second one is right, of course, because they are in fact part of a larger scale individual. So are we part of it? I don't know. I think maybe it's possible. And again, this is maybe Roy can say something about this. Is it possible for us to gain evidence that we are part of a collective that has collective dynamics like learning, like preferences, like attention? I don't know. I was contacted by some guys who work on the market. What did they call it? The market mind hypothesis or something. But it's some kind of attempt to understand economics using some tools of behavioral science. I mean, I don't know. Maybe some of these concepts like training, like attention, like perceptual illusions. Maybe they would work on these larger structures. That ant colonies fall for the same visual illusions that mammalian nervous systems do. Not the individual ants, the colony. So you can do experiments. They make the same perceptual mistakes as we do. You can use say many of the same illusions. I don't know. Maybe in economics that thing holds too.
I'm still intrigued by the question. I think it was Adam brought it up. Is there something that it's like to be a country?
And, yeah, let me find it.
I don't.
Mike, is the paper you're referring to there, does it have the line in it, what if we all held hands?
I don't recall, but I will.
There's something, I think it was Ned Block, and it might have been in What It's Like to Be a Bat, or a paper in that same space, but it was addressing arguments against the possibility of something like that. And one argument is just like it has to be physically connected. So that was just like a joke. What if we all held hands? But
Oh yeah, here.
I think the more serious take on that is something like there needs to be some physical medium for information exchange. And, back to this like cosmic neuron idea, I think it's dangerous getting psychologists to comment on quantum physics, but I'll take that leap there. I mean, when you hear about things like entanglement, where you have what seems to be like genuine information exchange across large physical distances where there's no actual contact, I don't know what to make of that. But then if I start thinking about it in more of these, like, treat the universe or just some high level system as some computer essentially that can transmit information, almost like there's again this planetary synapse going on. I wonder if there's anything there.
Yeah, maybe. My understanding, and I'm no physicist, but my understanding is that you actually can't use entanglement to pass information faster than light. That's my understanding, that you're not actually passing a signal back and forth. You're not violating relativity. But nevertheless, there is an interesting notion of synchronicity here. So Pauli and Jung, right? You might have seen that wrote this book on synchronicity, and it's this idea that patterns that look like anomalous information transfer at lower scales are in fact perfectly reasonable cognitive kinds of things at a larger scale that you're not aware of. And that's something that I'm working through right now. Richard Watson and I are working through some of this stuff right now. So I don't know, but check out. So I put a link on the chat. So this is a paper by Eric Schwitzgebel, and it's called "If Materialism is True, the United States is Probably Conscious." And it addresses exactly the issue that you're talking about. It's sort of basic philosophy.
I like Schwitzgebel. He's sympathetic to panpsychism as well.
Oh yeah, I don't know him at all, but I thought this was a pretty good paper. But I don't know anything here really, but the one thing I really feel strongly is that our intuitions for what kind of systems are going to have an inner perspective are not calibrated well. We have an N of 1 example. I mean, ourselves, like we really just have no clue. And I don't know. Yeah, I don't know about you, but if I didn't know what was between my ears and somebody showed me a brain and said, look, this thing is going to have an inner perspective. Why would you ever think that? Right. I don't know. I don't think, I mean, people have tried, right? So there's, IIT and some other things that try to, put down some constraints around the kind of architectures that are going to have that metric. But yeah, I think we're very brain focused, and I think that blinds us to a lot of things that, yeah, I don't know.
Maybe brain focused, but it's hard to imagine the United States being conscious as a thing.
Hard to imagine, but to look, are we good at imagining a lot of things that are true? I don't know. And I also think, right, without getting too out there, but I find it very difficult to imagine that in the whole universe, the only way to be conscious is to have this kind of thing here, right? Like that strikes me as a priori very improbable. I sort of have this background, maybe it's too much Star Trek when I was a kid, but I have this background expectation that the universe is a very weird place and that there are going to be minds out there that don't look anything like us. And if we're expecting to see a frontal cortex with this and that, we're going to be, badly disappointed. I just can't imagine that this is the only way to do, so you can imagine, right? I mean, this is sci-fi has had this for over 100 years. Like, you're sitting there at home and this thing lands on your front lawn and some kind of thing on wheels trundles out and hands you this poem of like, how happy it is to meet you. So what are you going to do? Are you going to assume that who knows what's in it? And you're going to assume that it's somehow faking because you can't find a single neuron in there? That can't be right. I don't know.
The idea that the corporation is like a person, that was a deliberate invention, a cultural invention as a fiction, which facilitated trade. It was a big advance, and it's one of the reasons that the Arab Islamic world fell behind, even though it was historically ahead for a number of centuries. But it's understood as a fiction. You don't think the partnership itself is conscious as a unity, but it's the key was to protect the individuals involved from liability. So if three Arabs want to get together to make an investment and send out a ship and profit by trade, if it goes bad, their whole fortunes, their house and everything is forfeit. And so it made trade very risky. But the Europeans invented the corporation. And so if it fails, then the assets belonging to the corporation can be accessed by the creditors. But the homes and the personal savings of the individuals are not at risk. But it's a legal fiction. It's understood as such. To say that the corporation becomes conscious as a unity seems a stretch to me.
But you know that actually, I mean, that's very interesting what you just said, that this kind of the adoption of an agential perspective makes certain relationships easier. I think that's very interesting. But there are a lot of philosophers of mind who think that the human consciousness is fiction too, right? And basically, I think they would tell exactly the same story that you just told around primates, sitting around a fire at some point, where it just basically this idea that we're gonna assume that each of us has an internal perspective that's like me is just a lubricating fiction for being a band of cooperating individuals, that there actually is no such thing. I mean, that's a pretty common, probably the majority, I guess, view nowadays in philosophy of mind, and that's in fact exactly that kind of fiction. It's a fiction that makes it easier to be successful and to do things, and then eventually it's a fiction that we turn on ourselves, right? That basically, after you tell stories about other agents doing things, then you say, wait a minute, I'm an agent too. I do things. I have free will, and I'm a person. And that basically is just a user illusion. Yeah, there are plenty of people who write books on human consciousness where that's the conclusion. That you're basically a user illusion that provides for social lubrication.
I'm not familiar with that perspective, I guess.
No, I mean, I don't want to I could name a number of books that would it's a very mainstream thing. I mean, it's it's very hard to sort of internalize that view, because it basically says that you are a walking illusion in many ways, but that is, I believe, the kind of the mainstream perspective.
I read a bunch of things about the self being an illusion and so on, and it's none of them seems very convincing. That I noticed they all put their names on their books.
Yeah, well, that's true, and that's sort of, that gets back to the issue. I think Adam mentioned free will at the beginning, right? That's it. I had lunch with a philosopher once who didn't believe in free will, and the waitress came by and said, well, what do you have? And they said, well, let me see. And I said, are you going to choose a sandwich? What how come you don't sit back and see what the Big Bang ordained? Yes. It's impossible for us, right? It's not. Right. I've never met anybody who can actually, So people say they don't believe in free will, but I think it's a false introspective report. They don't act as though they don't, and so you would never. Would you agree with that? I mean, you would never conclude actually from observing them that in fact they don't believe it.
Yeah. I think. I was talking about Metzinger, the German philosopher who wrote some book, or one of them, about there's no free will and no moral responsibility. And someone asked him, okay, is this how you raise your sons? No.
Of course.
They have to learn to behave by the rules.
Oh, yeah.
In these mainstream reductionist views arguing against free will, I mean, I don't disagree with their logic, but they seem to frame it as all or nothing. So if you don't have, say, independence from this entire causal chain of the universe, then there's none, as opposed to taking more of this degrees of freedom approach like Kevin Mitchell or Roy do, or this cognitive light cone approach that can be narrow or broad and give you more freedom.
Why would that even evolve? What would be the advantage of being able to act completely independent of the environment? Everything else that serves no purpose. What you want to do is spot multiple possibilities in the environment and make advantageous decisions on that basis.
Well, that's right. I think a lot of these accounts are very backwards looking. So it's all about explanations and pointing out that, well, look, there's this whole chain of chemistry going backwards that's responsible for everything that happens. And that's fine if you want to take the micro reductionist perspective and you're content with looking backwards at what's already happened. But that isn't what we're trying to do here. Right? I'm not interested in explanation. I'm interested in invention. I want to know what next. What are you going to do next? And that kind of framing where you're just looking back and thinking which atoms zig and zag to get you here are completely useless as a frame for invention. You're not going to do anything new if that's it. In fact, I just a couple of days ago, I wrote this. I had this blog post where I asked GPT-4 to write a dialogue between a hiring manager at a software company and a young applicant who just read one of these books saying there's no free will. So he goes in there and they say, so are you a good coder? He says, code? The computer is a physical system. The electrons go where they go. What do you mean code? There's no room for this magical code that's going to make the electrons dance. They just, the computer does what it does. And that's exactly right. If your perspective is that everything is going to happen according to the Maxwell's equations where the electrons go, you're not going to code a damn thing. And you're a terrible candidate for a job that requires forward-looking creativity. Backwards is easy. Forwards is where it's at.
Yeah. Oh. Well, I see we're in the final couple minutes. Thank you, Michael, for doing this, and thank you, Adam, for setting it up. This has been very stimulating, giving me a bunch to think about.
Yeah, thank you both. If you have time, I wanted to ask one more question. Mike, you brought up Jungian synchronicity, and we haven't talked about any of this, Roy, so I'm curious to hear your thoughts, but I'll add one more piece where some of what he says is very compelling to me. And then on the other hand, I have Steve Pinker as one of my advisors. So he looks at that in like very cognitive rationalist terms of, okay, this is just one of many biases that we have where chance events occur all the time. And most of the things that have no meaning, you just completely dismiss. And then every now and then it's like type 1 error, right? Now and then you're going to get a false positive. And I go back and forth between thinking, yeah, when these chance encounters happen that hint at something connected, is that just me imposing like my predictive processing onto the world? And it's really just things happen all the time, so there's bound to be coincidences.
Yeah. I really liked Jung when I was young. I read a whole bunch of his books. I even had plans to go to the Jung Institute and learn that. And somebody kindly talked me out of that. He was certainly brilliant and operating in the outside the normal range, and that's part of the appeal to try these things. But the synchronicity, you have to postulate there's some higher power integrating or organizing things. It's a variation of the everything happens for a reason argument. And in terms of human evolution, a lot of things happen for a reason, and that's how we learn to relate to each other instead of just looking at each other as like, oh, there's an animal doing something. How does this affect me? But you start to infer, well, the person is doing that for a reason, which we can infer. And so we learn to think in terms of invisible causes behind things. But the synchronicity, to take random coincidences and see a deeper meaning, that's seductive. But I guess I believe there's a lot of randomness in the universe. So I'm not really a believer in synchronicity as a thing. Now some things do happen for a reason, and there are, you can explore coincidences, and some of them will not be coincidences, but a lot of them are.
Right. When it gets all mystical, it seems to fall on its heels. But when I
He
think
certainly
about
does, yeah.
Mike's example of the comic strip, neurons talking to each other, firing really in accordance with a
That's
whole
good.
plan
Yeah.
of a higher intelligence that they can't perceive, and then thinking about how narrow our perception is, and just
Right.
thinking, is
Yeah.
it possible that there's some like large scale computation that we're all part of, and thinking about, I don't know, this evolutionary game theory or these sort of natural laws of selection that are guiding in a certain way, and then other people
Yeah.
say, you know, it's not selecting for some end goal, it's just selection just is, and what survives just is.
Yeah, I think you know, I think the question of whether there's a larger pattern is an empirical question. So I'm not going to claim an answer to that, but I do think that the concept of synchronicity, and I've only recently started working on this. I don't have a mature version of this idea, but I'll just spit this out, that I think the concept of synchronicity goes way beyond our human tendency to notice patterns. I think that a proper version of the concept of synchronicity would talk about multi-scale patterns, so that when you're looking at electrons in the computer, you would say, isn't it amazing that these electrons went over here and those went over there, but together that's an AND gate. And by the way, that's part of this other calculation. Like, amazing. Down below, all they're doing is following Maxwell's equations, but looked at another level, wow, they just computed the weather in, you know, in Chicago. So I think what, you know, it's not about, well, I was going to say it's not about us and our human tendency to pick out patterns and things, but actually I do think it's that too, because if synchronicity is simply how things look at other scales, of course we're going to get good at it, and of course we're also going to make mistakes, right? We're not going to be perfect at it. We're going to be looking for these kinds of things, and sometimes we're going to overdo it. But that's not to say that there are mundane explanations, right? Things that look random and physical and deterministic at one scale, you're missing a lot if you don't know if there is a different scale of observation. And it's like, yeah, you could study your computer using Maxwell's equations, but you're really better off if you know what a high level programming language is. And that is total mysticism from the perspective of the electrons. This idea that there's this giant algorithm that's, you know, determining where we go. It's mystical nonsense. Except that if you don't buy into that, you're not going to code much. We would still be, you know, we would still be in the 50s as far as information technology if we didn't buy into that particular brand of mysticism. So I feel like there's definitely a revolution along those lines coming for biomedicine. And this our obsession with the biological hardware and with the molecules instead of the expectations, the memories, the preferences of our collective cells and so on. That's, you know, I'm betting a lot of our lab work on that's all got to change. But maybe it goes higher than that, you know. I don't know, but anyway, yeah, again, same thank you so much for putting us together, Roy. Real pleasure.
Yeah, for me too, Michael. Yeah.
Please send over, if you don't mind, if you have anything that's relevant to this from your work that I should read, definitely send it over. I'd love to.
All right.
Yeah.
Okay, well, thanks again.
Yeah, thanks, Adam.
This was super interesting. Thank you both.
Yeah, thanks, guys.
Appreciate it. Thanks, guys. Bye.
See you later.